All right, guys. Today we're going to do the second part of graphing, which are kind of the weird, a little bit weirder special cases, which I have 4 examples here. And so there's 2 things that you probably notice here. The first thing that you notice is that neither of these 2 problems right here have zeros. And the reason for that is because my horizontal asymptote is at y equals 0. So it goes through, which makes there not be any zeros. And then these 2, you might notice that there is no horizontal asymptote, and the graph kind of does this funky deal where it comes at an angle right here and right here. So I'm gonna tell you why that happens, so that when we're trying to write the function from these graphs, we know what's going on. So starting with these first 2, I told you guys that you're gonna turn the problems in for this video, that you have video problems, and we're really just gonna do these 4 problems together, and then you're gonna turn them in. So it's just essentially, if you do the problems that I do right now, you'll get the credit. So if I remember way back when I first learned this stuff, the rules for horizontal asymptote were that if the degrees were the same on the top and the bottom, like this, then I divide the leading coefficient. So this would have given me a horizontal asymptote of y equals 1. If the degree is higher on top, then I have no horizontal asymptote. And if the degree is higher on bottom, then I have a horizontal asymptote at y equals 0. So I want to keep that in mind when I'm looking at these. These have a horizontal asymptote at y equals 0, both of these 2, which tells me I know that the denominator of my fraction needs to have more pieces than the numerator of my fraction. So when I'm writing this, I'm going to keep that in mind, okay? And if something doesn't add up right, then I'm gonna put it together. So f of x equals horizontal asymptote. When it's 0, you're not going to put it in the front. You're just going to put nothing there. And I don't have any zeros, so I have nothing to put on top right now. So I'm not going to put anything on top. Just going to do my vertical asymptotes at 3, so x minus 3. And negative 3, so x plus 3. And then I notice right here I have a hole. I don't know if y'all could see that. Let's see if we can zoom in. I have a hole right there. So the way that I do a hole is I look at where it is on the x-axis, meaning I'm going to count over to it. So 1, 2, 3, 4, 5, 6, 7. It's at negative 7. So on my function, I'm going to put x plus 7 on the bottom and the top, because that's going to give me a hole. And then this piece, I didn't have to use it for anything. So that's the function for the first problem. And that's all that I needed to do. Okay, I'm going to go along and do the same thing on the second one. I'm going to go through the process. Again, I don't have any zeros, so I can't do that. Horizontal asymptote is 0, so I'm not going to put anything there. Vertical asymptote at 1, 2, 3, 4. So I'm going to put x minus 4. And then I have a hole right here at 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to put x minus 9 on the bottom and on the top. So that's what gives me a hole. And then I also have a hole right here at negative 1, 2, 3, 4, 5. So I'm going to put x plus 5 on top and bottom. So remember I told you, in order for it to be horizontal asymptote at y equals 0, the degree on top needs to be smaller than the degree on bottom. So notice I have 3 x's here and I only have 2 here, which means on top it's going to be x squared, and on bottom it's going to be x cubed. So that did work out. I had a higher degree on bottom than on top. And on this one, on top is just x, and down here I have 3 of them, so it's going to be x over x cubed. So it is a higher degree on bottom than on top. All right, now we're going to do this guy here. So on this one, I do have zeros. I have zeros at -1, and I'm going to call that +2. So I'm going to go x plus 1, x minus 2. Oh, I'm not on the screen. Like this. How about that? I don't have a horizontal asymptote, so I have nothing to put there. I have a vertical asymptote at 1, 2, 3, 4, 5, -5. So if I look at this, I have x squared on top and x on bottom, which means I shouldn't have a horizontal asymptote because the degree is higher on top. And I don't have a horizontal asymptote. So that's it, unless there's some holes, and there's not, so that's it. Fourth one, I have a 0 at 1, 2, 3, 4, 5. I'm going to call that 6, and I'm also going to call it 7. So I have -6 and -7. So I'm going to go x plus 6, x plus 7. And then I have a vertical oh, I did those backwards. Whoops. X plus 6, x plus 7. Those were my zeros. I have a vertical asymptote at -3, so I'm going to put x plus 3. And no holes, nothing else. This should be a higher degree on top. I have 2 on top and 1 on bottom, so it is. And that's why I don't have a horizontal asymptote. So today I'm going to give you some that are a little bit like this. Some with holes, some with no asymptote, some with asymptote at y equals 0. We're still following the same process. We're still just putting the pieces that they gave us onto the paper.